Hi and welcome to this Leaving Cert Higher Level Applied Maths video. In this video, we're going to look at a previous exam question. So this question is from the 2024 Higher Level paper and it's question 3 part A. Particle moving along a straight line has acceleration a dv dt equal to t squared sine 2t, where t is greater than or equal to 0 and v equals 0 when t equals 0. Using integration by parts or otherwise, calculate v when t is equal to pi over 2. So this is a really good reminder that anytime we're working with integration or differentiation, any calculus, our angles must be in radians. So I go through that in more detail in our video where we look at the basics of integration, which is linked in the description below. So this question has very nicely told us that we're going to be using integration by parts, so we don't have to worry too much about the identifying. So our first step here is to write down our differential equation, which is dv dt is equal to t squared sine 2t, and then we separate it. So we can see that everything on the right hand side has a t, so nothing is coming over. We're just going to bring that dt over to the right hand side. So it looks like this, and then we're going to integrate. Our limits of integration, we're told that when t equals 0, v equals 0. So when t is 0, v equals 0, and that gives us, then we want to calculate v when t is, I'm going to go straight to pi over 2. That's going to make our lives so much easier. You are welcome to go to t and then sub in your pi over 2. It's completely up to you. So we're doing integration by parts. So here is our formula, and we need to remember when we're doing integration by parts, inlate, which means the order that we have for our parts must be inverse, then log, then algebra, then trigonometry, then exponential. So we have two pieces here. We have t squared, which is algebraic, and then we have sine 2t, which is trigonometry. So these are currently in the correct order. So I'm going to bring these over. I'm going to leave my limits in the main question just for a second. 2t dt. This is the integral of u dv, this is my u, this is my dv. So we have u equals t squared, so we differentiate that. Du dt is equal to 2t, so du is equal to 2t dt. And then we have dv is equal to sine 2t dt, and we're going to integrate both of these, which gives us v equals. So when we integrate our sine 2t, we're going to get minus cos 2t divided by 2. So just be really careful that you're looking at page 26, which is integration, because integration and differentiation of our trigonometric are very similar. Don't rely, maybe in an exam, don't rely on your memory for this. Really do double check. And remember that we have the basic chain rule here, because it's a 2t, not just a t, so we're going to divide by that derivative of the inner function. So then in order for us to get an answer, we have uv minus the integral of v du. So that's going to be for us u, which is t squared, move this down a bit, t squared times v, which is minus cos 2t all over 2 minus the integral of v minus cos 2t over 2, and du is 2t dt. So there is a 2 on the top and a 2 on the bottom here. That's very nice. So this little bit turns into minus t squared cos 2t all over 2. That bit's fine. Minus minus, I can pull that minus out. It gives me a plus, and this gives me a t cos 2t dt. Now, here's the thing. This little piece here requires integration by parts again. So we need to go and do our integration by parts. So what I'm going to do, so we don't lose anything, is I'm going to go back to my main question, and I'm going to integrate the left-hand side, which is v, and evaluate between 0 and v. And then here on the right, we get minus, and this is all going to be in a big box because it'll all need to be evaluated in the end. t squared cos 2t all over 2 plus the integral of t cos 2t dt, and when we do all that, it's going to be evaluated between 0 and pi over 2. So I'm just going to clear the screen so we have a bit more space, and we're going to do integration by parts again. This is a common occurrence when we have sometimes when we have exponentials and trigonometric functions, they can actually get caught in a circular loop. We look at how to deal with that in the basics of integration video. Here, just a second time using integration by parts, and we will have our answer. So we have just a bit more space to work. So the left-hand side is going to be v minus 0, which is just v. We still have that minus t squared cos 2t over 2. And I'm going to look at that second part of the right-hand side. So this bit here, and that is going to need integration by parts again. So get in late. We have a t, which is algebraic, and we have a cos 2t, which is trigonometric. So we are in the right order. So let's take a look at t cos 2t dt. This is the integral of u dv. U is my t. My dv then, I don't really have enough space to draw an arrow, but we'll just underline the whole thing. That is our dv. So we have u is equal to t, meaning du dt is equal to 1. So du equals dt. And then we have dv equals cos 2t dt. We're going to integrate both sides. So v is equal to, cos becomes sine, and that's 2t, and we're dividing it by 2 again. It's that version of the chain rule. So then when we are doing our integration by parts, we have uv minus the integral of v du, which is going to be u, which is t, times v sine 2t over 2 minus the integral of v sine 2t over 2 du, which is dt. So this gives us t sine 2t over 2. And I'm going to pull that half out in front just to make that integration a little bit easier. So it's sine 2t dt, which is t sine 2t over 2 minus a half. Sine is going to go to minus cos 2t over 2. So when I put that back in, I get a plus t sine 2t over 2. Minus by minus is a plus, and then we have a half. So we have a 2 and a 2 on the bottom line. So we're going to have cos 2t over 4. So that's our full integral before we start evaluating it. So like I said, you can go between 0 and t. I'm going to go straight to pi over 2 because that's the answer that we want. And you're also welcome to use the idea of the constant of integration and do substitution. I think the limits method is a lot more efficient and it's less prone to error, and it is a few less steps. So let's work what we have. So minus pi over 2 squared cos of 2 times pi over 2, which is just pi. You're welcome to put that in as 2 times pi over 2, but just to save typing when we get to the calculator stage, and just to save writing as well, I'm just going to put that in as pi for each of them. Cos pi over 4. And then we're going to subtract minus 0 squared cos 0 over 2 plus 0 sine 0 over 2. So, and then we have cos 0 over 4. Be so careful. Subbing in a 0 does not always get us a 0. Here, that disappears because we're multiplying by a 0. However, the cos of 0 is 1, so we get a quarter there. So what we end up with here, if we start evaluating it, so minus pi over 2 squared cos pi over 2, that gives us pi squared over 8. Cos of pi is minus 1. And then we have pi over 2 sine of pi. Sine of pi is actually 0, so this whole thing ends up giving us a 0. Plus cos pi over 4, which is minus a quarter. I'll actually go straight to just minus a quarter. And then we have minus, and then 0, 0, and that's plus a quarter. So what we end up with is pi squared over 8 minus a quarter, which is minus 2 quarters or minus a half. And it's fine to leave your answer like that. Or if you want to change that to decimal, correct 3 decimal places, we get 0.73.